pause for a moment. If, while falling asleep tonight, your mind drifts through Martian dust into the storms of Jupiter and through the quiet winds of Neptune, your rest may grow deeper. This is not about staying awake. It's about letting your thoughts wander slowly, without effort. Tonight, we're not rushing through space. We're simply allowing ourselves to feel it. Now, let's begin. The solar system is always in motion, yet it never feels hurried. Every planet, moon, and particle of dust follows a smooth, curved path shaped by gravity. Nothing travels in straight lines here. Everything is gently falling, endlessly missing, and perfectly balanced. This system formed around 4.6 billion years ago when a massive cloud of gas and dust slowly collapsed. As it turned, material gathered at the center, forming the sun. The remaining matter settled into wide orbits, becoming the planets and smaller bodies we see today. That ancient movement never stopped. It only became quieter. The sun contains nearly all the mass in the solar system. Its gravity holds everything together. Deep in its core, hydrogen atoms are forced together under extreme pressure, releasing energy. That energy takes thousands of years to reach the surface. Once free, it crosses space and reaches Earth in just over 8 minutes. Closest to the sun, Mercury turns beneath a nearly airless sky. With no thick atmosphere to hold warmth, its surface experiences extreme temperature changes. Atoms released from the ground escape easily, drifting into space almost as soon as they appear. Venus follows, wrapped in dense clouds that trap heat. Its rotation is unusually slow and moves in the opposite direction of most planets. Without a strong magnetic field, the solar wind gradually strips lighter elements from its atmosphere, altering the planet over long periods. Earth exists in a quieter balance. A dense metal core generates a magnetic field that shields the planet from harmful radiation. Large surface plates move slowly, reshaping continents and recycling heat. Oceans absorb warmth during the day and release it slowly, helping maintain stable conditions over time. Farther out, Mars rests beneath a thin atmosphere. Its surface shows signs of ancient activity, including vast volcanoes and deep valleys. Fine dust blankets the planet, and powerful storms can spread across its entire surface, dimming sunlight for weeks. Beyond Mars, space opens wider. Distances grow, orbits stretch, motion slows, but never stops. And as we continue outward, the worlds ahead become colder, larger, and distant, revealing forms of motion shaped by darkness and time. This is only the beginning of the drift. As we move farther from the sun, the warmth fades slowly, not all at once. Light grows softer, distances stretch wider, and gravity begins to feel different here, stronger, heavier, more commanding. Beyond the orbit of Mars, the solar system opens into a broad, quiet region where countless rocky fragments drift in silence. This is the asteroid belt. Despite how it's often imagined, it is not crowded or chaotic. The space between individual asteroids is vast. Most of the time, nothing passes close to anything else. Motion here is patient and uninterrupted. Some asteroids are not alone. A few have small moons, tiny companions held in gentle orbits. These miniature systems show that gravity does not need size to create balance. Even small bodies can hold on to something quietly for millions of years. Far beyond this calm region, gravity begins to deepen. Jupiter waits ahead, immense and unavoidable. It is the largest planet in the solar system, containing more mass than all the other planets combined. Its gravity shapes everything nearby, bending paths and capturing passing objects. Jupiter does not rest. Thick bands of clouds move endlessly across its surface, driven by internal heat. Unlike Earth, Jupiter releases more energy than it receives from the Sun. This warmth comes from slow gravitational contraction deep within the planet, a quiet process that has continued since its formation. Within Jupiter's powerful magnetic field, space itself becomes dangerous. Charged particles are trapped and accelerated, forming intense radiation belts. These invisible regions are so strong that unprotected spacecraft could be damaged quickly. Beauty and danger exist together here, unseen but constant. Orbiting Jupiter is a family of moons, each shaped by gravity in different ways. Some are frozen solid, others hold thick atmospheres or liquid lakes made not of water but of methane and ethane. Chemistry here behaves differently, slowed by cold, shaped by time. With every step outward, the solar system becomes colder, darker, and more spacious. Motion continues, but it feels slower now, stretched across enormous distances. And ahead, even stranger worlds are waiting, tilted, frozen, and wrapped in winds that never touch the ground. We keep drifting. Gravity still holds us. As we continue outward, the sun becomes smaller, its warmth thinner, spreading gently across a much larger space. Here, the solar system begins to feel quieter, but also stranger. The rules haven't changed. Gravity still guides every movement, but the results are more unusual now. Uranus appears first, pale and distant, rolling slowly through space. Unlike most planets, it does not spin upright. Instead, it is tipped almost completely on its side. This extreme tilt causes seasons unlike anything near the inner worlds. For decades at a time, one pole faces the sun continuously, bathed in faint light, while the other remains in darkness. Then, slowly, they switch. Day and night here are measured not in hours, but in generations. Despite its calm appearance, Uranus is not inactive. Beneath its clouds, heat flows outward, though less strongly than expected. Its atmosphere moves quietly, shaped by cold temperatures and long, slow seasons. The planet carries scars of an ancient disruption, likely caused by a massive collision early in its history, leaving it forever tilted. Farther still, Neptune waits at the edge of the familiar planetary region. Light from the sun is weak here, more than 30 times fainter than on Earth. Yet Neptune is far from still. It holds the fastest winds ever observed in the solar system. These winds race through its atmosphere at incredible speeds, driven not by sunlight, but by heat rising from deep within the planet. Neptune's blue color comes from methane in its atmosphere, which absorbs red light and reflects blue. Storm systems form and fade, moving across the planet like slow, silent waves. Even in the coldest reaches, energy finds a way to move. Around these distant planets, moons follow quiet, looping paths. Some are smooth and frozen. Others show signs of internal activity, warmed by constant gravitational stretching. Ice cracks, shifts, and slowly reshapes itself, even without direct sunlight. Farther still lies a vast region filled with icy remnants, leftovers from the solar system's formation. These objects rarely interact. They wait in darkness, holding their ancient positions. Out here, motion feels stretched thin across time. A single orbit can last longer than human history. Change still happens, but so slowly it becomes almost impossible to notice. The solar system does not end suddenly. It simply fades, becoming quieter, colder, and more distant, until gravity's influence weakens and the journey turns inward again. And even here, at the edge of familiarity, nothing is ever truly still. As we drift farther outward, the familiar planets slowly fall behind us. Their shapes soften. Their pull weakens. What remains ahead is not emptiness, but memory, cold, distant, and quietly preserved. Beyond Neptune and the path of Pluto lies a wide, flattened region known for its stillness. Countless icy bodies move here, each following a long, patient orbit around the Sun. These objects are remnants from the solar system's earliest days, material that never gathered into planets. They have remained mostly unchanged for billions of years, protected by distance and cold. Here, sunlight is faint and fragile. It takes hours to arrive, spreading thinly across frozen surfaces. Temperatures remain so low that gases like nitrogen and methane freeze solid. Ice behaves differently in this environment. Under pressure and time, it can slowly flow, reshaping landscapes without melting. Some of these distant worlds are large enough to pull themselves into rounded shapes. They rotate slowly, carrying thin, temporary atmospheres that appear only when they drift slightly closer to the Sun. As they move away again, those atmospheres freeze and fall back to the surface like silent snow. Farther still, the solar system becomes less like a disk and more like a sphere. Orbits tilt in every direction. Distances grow immense. This outermost region is thought to extend far beyond the planets, forming a vast cloud of icy objects that barely feel the sun's pull. Here, a single orbit can take tens of thousands of years. These distant bodies are rarely disturbed, but when they are, their paths can change gently, sending them inward after ages of waiting. When they approach the Sun, warmth awakens frozen material, ice turns to gas, dust lifts from the surface. A glowing tail forms, always pointing away from the Sun, shaped by light and solar wind. These travelers do not hurry. They move slowly, tracing long arcs through space before fading back into darkness. Many will not return for thousands of years, if they return at all. Out here, time feels different. Motion still exists, but it is stretched across spans far longer than human history. Change happens quietly, almost invisibly. Surfaces record ancient impacts that remain untouched, preserved like footprints in permanent snow. Even in this distant calm, gravity still reaches. It never fully lets go. Every object remains faintly connected to the sun, bound by a force that weakens with distance but never disappears completely. The solar system does not end with a wall or a boundary. It thins, it fades, it blends gently into the wider galaxy beyond. And as we reach this quiet edge, the journey begins to turn, not outward but inward again, carrying with it the calm of deep space and the memory of long, patient motion. Nothing here asks for attention. Everything simply continues. After drifting through the cold memory at the edge of the solar system, the motion begins to feel familiar again. Not faster, just closer. Gravity gently pulls inward, guiding the path back toward warmth without ever rushing the journey. As we move sunward, distant objects slowly fade behind us. Their long orbits stretch out of sight, and the sun grows brighter, not suddenly, but gradually, as if light itself prefers patience. Even here, nothing travels directly. Every return is a curve, shaped by mass and momentum working together. The outer planets begin to influence space once more. Their gravity subtly bends the paths of nearby objects, guiding dust, ice, and wandering bodies into stable motion. These giant planets act as quiet organizers, shaping the architecture of the solar system without ever touching what they guide. Jupiter's influence is felt first. Its immense gravity pulls in passing debris, capturing some objects and redirecting others. Many incoming bodies never reach the inner planets because Jupiter quietly alters their paths. In this way, motion becomes protection and mass becomes balance. As we continue inward, the space between orbits tightens now. Objects complete their journeys more quickly now. Years shorten. Change becomes easier to notice. Yet the calm remains. The solar system does not hurry simply because it grows warmer. Saturn's gravity shapes its surroundings with equal care. Its moons follow steady paths, locked into rhythms that repeat endlessly. Some moons gently tug on others, keeping orbits stable through constant, tiny adjustments. Nothing here is left unattended. Between the giant planets and the inner worlds lies a region shaped by countless small encounters. Dust particles collide softly. Tiny fragments spiral slowly inward, guided by light and gravity together. Over time, even the smallest forces leave their mark. Mars reappears beneath a thin sky. Its surface still holds the record of ancient change. Volcanoes, valleys, and plains remain mostly untouched, preserved by low erosion. Winds move dust across the surface, slowly rearranging the landscape without ever erasing it completely. Closer still, Earth's orbit waits in quiet balance. Here, gravity and motion maintain a stable path that has lasted for billions of years. The planet spins steadily day after day, while its orbit remains calm and predictable. This stability allows oceans to cycle, climates to settle, and life to continue without urgency. Venus follows nearby, moving along its slow, unusual rotation. Heat remains trapped beneath its clouds, unchanged by timescales familiar to us. Mercury traces its close path to the sun, enduring extremes with every turn. At the center of it all, the sun continues its steady work. It shines not with intention, but with consistency. Fusion proceeds quietly, releasing energy that flows outward in every direction, shaping motion across the entire system. The journey inward does not end. It loops. Motion repeats. Balance holds. And through every orbit, every return, and every slow drift, the solar system continues, calm, ancient, and endlessly patient. As the sun grows brighter again, the inner solar system begins its steady rhythm. Here, motion feels more familiar, yet it remains just as precise. Every orbit is carefully balanced. Every rotation follows a pattern shaped long ago and maintained without pause. Mercury moves closest to the sun, tracing an elongated path that brings it alternately near and far. With almost no atmosphere to soften the sunlight, its surface heats intensely during the day and cools rapidly at night. Rocks expand and contract with each cycle, slowly breaking apart over time. Change here is not dramatic. It is repetitive, quiet, and unavoidable. Venus follows, drifting beneath an unbroken layer of cloud. Its thick atmosphere traps heat efficiently, creating surface conditions that remain nearly constant. Winds high above the ground circle the planet faster than the surface itself rotates. This slow spin creates long days and nights, but the temperature barely responds. Venus changes very little from moment to moment, yet over immense timescales it has changed completely. Earth's motion feels gentler by comparison. Its orbit is nearly circular, helping maintain stable seasons. The planet spins at a steady pace, creating regular cycles of light and darkness. Beneath the surface, heat rises slowly from the interior. Plates move a few centimeters each year, reshaping continents without sound. Mountains rise, oceans open and close, and carbon cycles through air, water, and stone. Earth's magnetic field stretches far into space, forming a protective region that deflects charged particles from the sun. When some of those particles slip through near the poles, they create soft glows in the upper atmosphere. These lights drift and fade without noise, visible reminders of invisible forces at work. The moon moves alongside Earth, locked into a stable relationship. It turns once for every orbit, always showing the same face. Its gravity gently stabilizes Earth's tilt, helping maintain long-term climate patterns. On the moon's surface, footprints can last for millions of years, untouched by wind or rain. Between Earth and Mars, countless small fragments travel quietly. Dust particles spiral slowly inward, nudged by sunlight itself. Over time, this fine material either burns up in atmospheres or settles onto planetary surfaces, adding thin layers to worlds below. Earth completes its orbit farther out, its weaker gravity unable to hold a thick atmosphere. Water once flowed here, carving channels and valleys. Today, most of it is locked away as ice. The planet turns calmly beneath its thin sky, preserving its ancient features with little erosion. Throughout the inner solar system, motion remains steady and predictable. Years pass, orbits repeat. Nothing needs to change quickly for balance to remain. The sun continues to shine at the center, converting mass into energy second by second. Its light spreads outward, touching every world in turn, before fading into the distance. And with each quiet rotation and every gentle orbit, the inner worlds continue their work, slow, consistent, and perfectly timed. As the inner worlds continue their steady paths, something less visible becomes easier to notice. Time itself behaves differently across the solar system. It does not move at exactly the same pace everywhere. Gravity, mass, and motion quietly shape it. Near large objects like the Sun and massive planets, time passes just a little more slowly. This effect is subtle, impossible to feel, yet precise enough to measure. Satellites orbiting Earth must constantly adjust their clocks to stay accurate. Without these corrections, even everyday navigation would slowly drift out of sync. Light carries these differences with it. When sunlight leaves the sun, it travels freely through space, unbothered by distance or silence. But as it passes close to massive bodies, its path bends slightly. This gentle curve reveals the quiet strength of gravity, shaping even something as fast and intangible as light. Throughout the solar system, sunlight behaves differently depending on where it lands. On Mercury, it strikes the surface sharply, creating intense brightness and deep shadow. On Venus, it filters through thick clouds, scattering and softening before ever reaching the ground. On Earth, it spreads through air and water, warming land slowly and unevenly. Farther out, sunlight weakens. By the time it reaches Jupiter and Saturn, it is faint and cold. These planets rely less on sunlight and more on internal heat to drive motion. Storms rise not because of solar warmth, but because of energy trapped deep within. Radiation moves alongside light. Charged particles stream outward from the sun, forming the solar wind. This flow is continuous, invisible, and quiet. When it encounters a planet's magnetic field, it is redirected. Where no such field exists, particles strike directly, slowly altering surfaces and atmospheres. Over long periods, these gentle forces reshape entire worlds. Atmospheres thin or thicken, surfaces darken or brighten, ice migrates, dust settles. None of it happens quickly. The solar system prefers patience. Even space itself is not empty. Sparse particles drift between planets, magnetic fields stretch and twist. Small forces act over enormous time spans, producing large effects without ever announcing themselves. Moons continue their steady companionship. Some are locked in place, rotating once per orbit. Others slowly drift farther away or spiral inward. These changes are nearly imperceptible year to year, yet over millions of years they reshape systems completely. Asteroids continue their quiet paths, rarely interacting. When collisions do occur, they are brief and decisive, followed by long periods of stillness. Debris spreads slowly, forming new patterns that persist for ages. Everywhere, motion continues without urgency. Forces remain balanced. Time passes unevenly yet predictably. Light moves on, carrying information from one place to another, linking the entire system together. Nothing here is rushed. Nothing here is accidental. The solar system unfolds gently, shaped by forces that act quietly, continuously, and without rest. As time and light continue their gentle work, the solar system reveals another layer of calm motion. Not all worlds travel alone. Many move in pairs or families, bound together by gravity in long-lasting relationships. Moons are the most common companions. They circle planets quietly, following paths shaped by distance and mass. Some orbits are nearly circular and stable, repeating the same journey endlessly. Others are stretched and tilted, creating slow variations that unfold over millions of years. Earth's moon remains locked in a steady rhythm, always showing the same face. This synchrony is not unusual. Tidal forces gradually slow a moon's rotation until it matches its orbit. The process takes time, but gravity is patient. Once complete, the relationship remains calm and predictable. Farther out, moons experience stronger tidal effects. Around giant planets, gravity stretches and compresses moons with every orbit. This constant flexing generates heat deep inside, warming otherwise frozen interiors. Ice cracks, melts, and refreezes slowly, reshaping surfaces from within. Some moons show smooth plains formed by ancient flows of ice or rock. Others are covered in craters, their surfaces unchanged for billions of years. Each tells a different story, written at a pace set by its environment. Not all companions are moons. Some asteroids travel with partners of their own. These small binary systems move together through space, orbiting a shared center of mass. They formed through gentle collisions or slow gravitational capture, then remained together, rarely disturbed. In rare cases, two objects of similar size orbit each other so closely that neither can be considered dominant. These paired bodies move in quiet balance, their mutual gravity keeping them aligned through long journeys around the sun. Even planets influence each other subtly. Their gravitational pulls create resonances, repeating patterns that stabilize orbits over time. Some moons are locked into these resonances, completing precise ratios of orbits that repeat endlessly without drifting apart. These repeating motions act like quiet agreements, keeping breakup and chaos at bay. When resonances break, systems can change dramatically, but most remain stable, preserved by balance and distance. Companionship also affects rotation. Tidal forces can slow a planet's spin or tilt its axis slightly. Over long periods, these changes alter climate patterns and surface conditions, reshaping worlds without sudden events. Beyond planets and moons, rings form another kind of companionship. Particles follow similar paths, sharing space without touching. Each piece moves independently, yet together they create smooth, continuous structures that seem solid from afar. All these systems rely on the same simple rules. Gravity pulls, motion responds, time allows balance to settle. Nothing here requires attention or intervention. The relationships hold because they have always held, reinforced by repetition and patience. In this quiet network of companions and orbits, the solar system continues its slow dance, each body aware only of the forces that guide it, never rushing, never stopping. As the solar system continues its quiet motion, not all calm appears the same. Some worlds remain peaceful on the surface, while others carry constant movement high above, hidden within thick layers of cloud. Giant planets do not have solid ground in the way Earth does. Instead, their atmospheres deepen gradually, growing denser with depth. Winds form easily here, free to move without mountains or continents to slow them down. Once started, these winds can last for centuries. Jupiter's atmosphere is layered into wide bands that circle the planet endlessly. These bands move at different speeds and directions, sliding past one another in slow, continuous motion. Where they meet, storms rise. Some fade quickly, others remain, drifting calmly for generations. One of these storms has existed longer than modern human history. It rotates steadily, fed by energy from below, changing shape but never fully disappearing. It is not violent in the way Earth's storms are. It is persistent, patient, and vast. Saturn's storms are quieter by comparison, yet equally powerful. At certain times, massive disturbances spread across the planet, wrapping it in bright clouds before slowly fading back into stillness. These events repeat on long cycles, separated by years of calm. Uranus and Neptune show different kinds of motion. Their storms are driven less by sunlight and more by internal heat. On Neptune, winds move faster than anywhere else in the solar system. They race through the atmosphere at incredible speeds, circling the planet without pause. Despite the cold and distance from the sun, Neptune releases heat from deep inside. This internal warmth fuels constant motion, proving that energy does not always come from light. Even in darkness, movement continues. Storms here are not chaotic. They follow rules set by rotation speed, temperature differences, and depth. Clouds rise, cool, sink, and repeat the cycle endlessly. Nothing seeks an end. Balance is maintained through repetition. Even Earth's atmosphere follows these same principles, though on a smaller scale. Warm air rises, cool air falls, winds form, storms grow and fade. The difference lies not in the rules, but in the pace and scale. Mars shows a quieter version of atmospheric motion. Its thin air cannot hold large storms for long, but fine dust can remain suspended. Over time, this dust spreads across the planet, softening contrasts and reshaping the surface slowly. Venus hides its motion beneath thick clouds. Winds high above the surface move much faster than the planet rotates. The atmosphere circles the globe again and again, while the ground below remains almost unchanged. Across the solar system, storms are not signs of chaos. They are signs of balance. Energy moves from one place to another, following paths shaped by gravity, rotation, and time. Nothing here needs to settle. Motion itself is the steady state. And as these storms continue their quiet work, the solar system remains calm, not because nothing moves, but because everything does. As storms continue their endless motion above distant planets, another quieter process unfolds beneath the surface. Not all change is visible from above. Some of the most important movement happens slowly, hidden deep inside worlds. Planets cool over time. Heat left from their formation escapes gradually, moving outward from the core toward the surface. This process can take billions of years. Even now, many planets still carry warmth inside, a memory of their violent beginnings. On Earth, this internal heat drives movement in the mantle. Slowly shifting rock carries continents across the surface, reshaping oceans and mountains without sound. A few centimeters each year is enough. Given enough time, entire worlds change. Mars once held more internal heat than it does today. When it was younger, molten material reached the surface repeatedly, building enormous volcanoes. With no moving plates to carry the crust away, eruptions stacked upon each other. Over millions of years, a single mountain grew taller than any on Earth. When the heat faded, the activity stopped, leaving the structure frozen in place. Venus holds its heat differently. Its thick crust may trap warmth beneath the surface, preventing steady release. Instead of constant plate movement, pressure builds slowly until it escapes in massive resurfacing events. Large portions of the planet may have been reshaped all at once, then left quiet again for long periods. Mercury cooled quickly. Its small size allowed heat to escape early, causing the planet to shrink slightly. As it did, the surface cracked and folded, leaving long ridges that still stretch across its terrain. These scars remain unchanged, preserved by time and silence. The giant planets release heat in another way. Deep inside, pressure turns material into strange states that flow slowly. As these layers shift, heat rises, feeding storms above. The motion is gentle, continuous, and endless. Moons are shaped by internal forces as well. Some remain frozen solid, their interiors cold and still. Others are warmed by constant gravitational stretching. This slow flexing generates heat without fire, allowing ice to melt beneath thick shells and then freeze again. In these hidden oceans, water may remain liquid for millions of years, sealed away from space. No sunlight reaches them. Their warmth comes entirely from motion and pressure, not light. Even small bodies feel these effects. Asteroids warmed early in the solar system's history, then cooled and hardened. Their interiors locked into place, preserving early chemical structures like time capsules. Across the solar system, worlds are shaped not only by impacts and storms, but by quiet internal work. Heat moves, pressure shifts, materials respond slowly. Nothing here changes quickly enough to notice in a lifetime, yet over deep time, everything transforms. The solar system is not frozen in place. It is slowly, patiently becoming something new, one quiet movement at a time. While many changes in the solar system happen slowly and quietly, there are moments when motion briefly becomes more direct. These moments are rare, but their effects can last for billions of years. Throughout the solar system, countless small objects travel in steady orbits. Most never meet anything else. Space is wide and distances are large. But occasionally, paths cross. When they do, the encounter is brief and decisive. Impacts shaped nearly every solid surface we see today. Craters mark moons, planets, and asteroids alike. Some formed early, when the solar system was crowded and collisions were more common. Others are much younger, fresh scars that stand out against older terrain. On worlds without thick atmospheres, these marks remain almost unchanged. The Moon preserves craters formed billions of years ago, their edges still sharp. With no wind or water to erase them, time simply passes over these features without altering them. Mercury shows similar preservation. Its surface is heavily cratered, recording a long history of impacts. Each crater is a frozen moment, a reminder of motion intersecting with stillness. Earth experiences impacts as well, but most evidence disappears. Water erodes, plates shift, volcanoes resurface land. Only the largest events leave lasting traces, and even those are eventually softened by time. Mars lies somewhere in between. Its thin atmosphere allows smaller objects to reach the surface, but its winds slowly reshape the land.
Craters remain, though softened, blending gradually into the landscape. In the outer solar system, icy surfaces respond differently. When impacts occur, ice behaves almost like liquid over long periods. Crater edges slump, floors slowly rise, features soften without melting, reshaped by gravity and cold. Asteroids carry their own record of collisions. Many are fragments of larger bodies broken apart long ago. Their irregular shapes and varied compositions reflect violent beginnings followed by long periods of calm travel. Some impacts do more than leave marks. They alter motion. A collision can change an object's spin, tilt its axis, or shift its orbit slightly. These small changes accumulate over time, redirecting paths and reshaping systems without further contact. Even dust plays a role. Tiny particles constantly strike surfaces, slowly darkening and smoothing them. This steady rain is gentle, almost unnoticed, yet it alters appearance over millions of years. Collisions are not acts of chaos here. They are part of balance. Energy is transferred, motion adjusts, systems settle again. After each encounter, the solar system returns to quiet repetition. Orbits stabilize, rotation continues, surfaces hold their marks in silence. Nothing seeks destruction. Nothing seeks stillness. The solar system simply allows motion to meet matter briefly and then moves on, leaving behind records written in stone, ice, and dust.
At the center of everything, the sun continues its quiet work. It does not flare constantly or burn unevenly. Most of the time, it remains steady, releasing energy at a pace that has stayed nearly unchanged for billions of years. Inside the sun, pressure is immense. Hydrogen atoms move so closely together that they fuse, forming helium and releasing energy. This process happens continuously, second after second, without pause. The energy does not rush outward. It moves slowly, taking thousands of years to reach the surface. When that energy finally escapes, it spreads in all directions as light and heat. Some of it reaches planets, some continues outward into space, thinning as it goes. Along with light, the sun releases a steady stream of charged particles known as the solar wind. This wind is not violent. It flows gently but constantly, carrying energy across the solar system. When it meets a planet's magnetic field, it bends and wraps around it, shaping invisible boundaries in space. Where no magnetic shield exists, particles strike directly, slowly altering atmospheres and surfaces. Earth's magnetic field forms a protective bubble, guiding most solar particles safely around the planet. Near the poles, some particles enter the atmosphere, releasing soft glows of light high above. These auroras drift and fade without sound, responding quietly to the sun's breath. Mars once had a similar shield, but it weakened over time. Without strong protection, solar wind gradually stripped away much of its atmosphere. What remains is thin and fragile, unable to hold heat or liquid water for long periods. Venus offers another outcome. Its thick atmosphere resists loss in some ways, yet without a global magnetic field, solar particles still interact directly with its upper layers. Over immense spans of time, this interaction has altered its composition. Farther out, the solar wind weakens. Its influence spreads thin across larger distances. Yet, even near the outer planets, it still plays a role, shaping magnetic environments and influencing the motion of charged particles. Beyond the planets, the solar wind marks the sun's reach. At a distant boundary, its outward flow slows and bends as it meets material from interstellar space. This region is not a wall, but a gradual transition where the influence of the sun slowly fades. Despite its constant output, the sun is slowly changing. Each moment of fusion converts a small amount of mass into energy. The loss is tiny, unnoticeable on human timescales, but over billions of years it adds up. For now, the sun remains stable, its rhythm unchanged. It does not hurry, it does not hesitate. Its steady breath continues to shape the solar system, touching every world in its own quiet way. And as that breath flows outward, planets, moons, and dust respond, not dramatically, but faithfully. As the sun's influence thins with distance, cold becomes the dominant force. But cold does not mean stillness. In the outer regions of the solar system, ice behaves in ways that feel unfamiliar, moving and reshaping worlds without ever melting. On many distant moons and dwarf planets, temperatures remain far below freezing. Water ice becomes hard as rock. Nitrogen and methane freeze into solid layers. Under these conditions, materials respond slowly to gravity and pressure, flowing over long periods like thick, frozen rivers. Some moons show vast plains where ice has smoothed away older features. Craters soften, edges relax, the surface changes not through heat, but through time. Gravity presses down, and ice yields, millimeter by millimeter, year after year. Beneath thick shells of frozen water, warmth can still exist. Tidal forces stretch these moons as they orbit their planets. This constant flexing generates internal heat. Ice cracks open, shifts, and sometimes seals again. Below the surface, liquid water may persist, hidden and stable, protected from space by kilometers of ice. These hidden oceans do not rely on sunlight. Their warmth comes from motion and pressure alone. If chemistry is present, reactions can occur slowly, steadily, without interruption. Conditions remain calm, insulated, and unchanged for immense spans of time. Farther from planets, dwarf worlds travel alone. Their orbits are long and stretched. As they move closer to the sun, frozen gases briefly awaken. Thin atmospheres form, drifting upward from the surface. When distance increases again, these gases freeze and fall back down, returning to silence. On these worlds, seasons can last decades or centuries. Change happens gradually. Nothing responds quickly. Ice migrates from place to place, following temperature and pressure like a quiet tide. Even comets share this behavior. For most of their existence, they remain frozen and inactive, resting in darkness. Only when they approach the sun does warmth reach them. Ice turns directly into gas, lifting dust from the surface. A faint glow appears, followed by a tail that stretches gently away from the sun. Afterward, they return to cold, carrying fewer materials than before. Each pass leaves them quieter, smaller, more settled. Across the outer solar system, ice records history the way rock does closer in. Layers build up, fractures remain, surfaces preserve the past without erosion or noise. Here, cold does not erase motion, it slows it. And in that slowing, the solar system reveals another rhythm, one where change is measured not in years or centuries, but in patient stretches of deep time. Ice moves, gravity guides, silence holds. As we drift once more through the middle of the solar system, attention turns to structures that seem solid from afar, yet are made of countless individual pieces. Rings and dust clouds form some of the most delicate patterns shaped by gravity. Planetary rings are not continuous sheets. They are made of billions of fragments, each following its own orbit. Ice, rock, and dust circle together, guided by gravity and motion. Though they appear still, every particle is moving at a slightly different speed, creating a constant, gentle rearrangement. Saturn's rings are the most visible example, stretching outward across enormous distances while remaining remarkably thin. In most places, they are only tens of meters thick. From the side, they nearly disappear, revealing how flat and delicate they truly are. These rings are not permanent. Over time, particles collide softly, breaking apart or sticking together. Some fragments are slowly pulled inward, guided by gravity and magnetic forces. Others drift outward. The structure changes quietly, grain by grain. Other planets have rings as well, though they are fainter and darker. Around Jupiter, Uranus, and Neptune, thin ring systems circle silently, made mostly of dust. These rings are replenished by small impacts on nearby moons, which release fresh material into orbit. Dust exists everywhere in the solar system. Fine particles drift between planets, following slow spirals shaped by sunlight and gravity. Over time, this dust settles on surfaces, darkening ice and softening features without sound. Light itself influences dust. Photons carry momentum, and when they strike tiny particles, they push gently. This effect is small, but over long periods it alters orbits, slowly drawing dust inward toward the Sun or outward into space. Between Mars and Jupiter, dust fills the region alongside asteroids. Collisions release fresh material that spreads slowly, forming a thin cloud. Even here, motion remains calm. Particles rarely meet. Most drift alone. Closer to the Sun, dust becomes warmer and more active. Some particles vaporize, others fall inward and disappear. New dust constantly replaces what is lost, keeping the system balanced. Moons embedded in ring systems act as quiet guides. Their gravity shapes gaps and edges, maintaining order within apparent chaos. These shepherd moons adjust orbits gently, preserving structure without force. Nothing in these systems is fixed, yet nothing falls apart quickly. Balance emerges naturally, maintained by countless small interactions repeated endlessly. Rings and dust remind us that the solar system is not built only from large worlds. It is shaped just as much by tiny pieces, moving patiently, guided by simple rules. Here, beauty comes not from stillness, but from motion shared by many. And as these particles continue their endless circling, the solar system holds together, softly, quietly, and without effort. Between the worlds we've passed, space feels open and empty. Yet even here, motion continues along invisible paths. Nothing drifts without guidance. Gravity still shapes every journey, even when objects are small and far apart. Most objects in the solar system follow predictable routes. Their orbits repeat with gentle precision, shaped by mass and distance. But some paths are less regular. They stretch, tilt, and slowly change, influenced by subtle forces acting over long periods of time. Comets follow some of the longest and most delicate paths. Many spend most of their existence far from the sun, moving through darkness where warmth never reaches. Their orbits can take thousands of years to complete. During this time, they remain quiet and inactive, holding their frozen material close. When a comet's path brings it inward, sunlight awakens it slowly. Ice near the surface turns directly into gas, lifting dust along with it. A faint glow forms, followed by a tail that always points away from the sun. This tail does not trail behind like smoke. It is shaped by light and solar wind, gently pushed outward. After the encounter, the comet continues on, returning to the cold. Each visit removes a small amount of material. Over many passages, comets become quieter, darker, and less active, slowly changing with every return. Asteroids move differently. Most remain within stable regions, circling the sun with little variation. Some, however, are nudged by gravity into new paths. A close approach to a planet can slightly alter an orbit, changing where and when the asteroid travels. These changes are usually small, but over long timescales, even tiny shifts matter. An object's path may slowly stretch or tilt, placing it on a course that intersects with different regions of the solar system. Dust particles follow even more delicate routes. Sunlight itself pushes them gently, causing slow spirals inward or outward. These particles rarely collide. Instead, they drift alone, responding quietly to forces too small to notice quickly. Spacecraft travel using these same rules. By passing close to planets, they borrow a bit of motion, adjusting their paths without using extra fuel. This technique relies entirely on gravity's patience, allowing long journeys to unfold efficiently. Throughout open space, nothing accelerates suddenly. Changes occur gradually, guided by balance rather than force. Paths adjust, orbits evolve, motion remains smooth. Even where space appears empty, it carries structure. Fields stretch, particles drift, light passes through, connecting distant regions without pause. The solar system is not crowded, yet it is not chaotic. Its openness allows motion to continue freely, shaped by quiet influences acting over deep time. Here, the journey feels effortless. Paths unfold naturally. Nothing needs direction. And as these quiet routes continue to guide worlds and wanderers alike, the solar system remains calm, not because it is still, but because it moves with care. As motion continues along quiet paths, time begins to stretch in another way. Seasons, which feel familiar on Earth, behave very differently across the solar system. They are shaped not just by distance from the sun, but by tilt, rotation, and patience. On Earth, seasons arrive and pass within months. The planet's axis is tilted just enough to create gentle changes in sunlight. Heat shifts gradually from one hemisphere to the other, guiding weather, oceans, and life through predictable cycles. But other worlds follow slower rhythms. Mars experiences seasons similar to Earth's, though longer and more extreme. Its orbit is more stretched, causing noticeable changes in temperature as it moves closer to and farther from the sun. Ice forms and retreats at the poles, releasing thin clouds of gas that drift across the surface before freezing again. Farther out, seasons lengthen dramatically. On Jupiter and Saturn, each season lasts several Earth years. Sunlight changes slowly, and internal heat plays a larger role in shaping weather. Storms rise and fade without urgency, responding more to deep energy than surface warmth. Uranus offers one of the strangest seasonal patterns. Its extreme tilt causes one pole to face the sun for decades at a time, while the other remains in darkness. During these long summers, sunlight barely moves across the sky. During equally long winters, the sun does not rise at all. Temperature changes occur slowly, delayed by the planet's thick atmosphere and internal heat. Neptune follows a similar pattern, though farther from the sun. Seasons there last more than 40 Earth years. Any change unfolds gradually, almost imperceptibly, as faint sunlight shifts across the planet's clouds. On distant dwarf worlds, seasons can last centuries. As these objects travel along long, stretched orbits, sunlight slowly increases and fades. Thin atmospheres appear briefly, then freeze and settle back onto the surface. Ice migrates from one region to another, reshaping landscapes without melting. Even moons experience seasons. Those with tilted orbits receive uneven sunlight, creating slow cycles of warming and cooling. On icy moons, these changes can cause surface cracks to open and close, responding gently to temperature and pressure. Seasons here are not about growth or harvest. They are about balance. Energy arrives, moves, and leaves at a pace set by distance and tilt. Nothing rushes to respond. These long cycles show how time can be experienced differently without ever changing its nature. A year may last days, decades, or centuries, depending only on the path taken around the sun. Yet through all these variations, motion remains steady. Orbits repeat, axes hold their tilt. Light arrives and departs exactly as physics allows. The solar system does not share one clock. Each world keeps its own. And as these slow seasons continue to unfold across distant planets and moons, the calm remains, carried forward by repetition and held together by gravity.
As seasons stretch and settle, another quiet influence becomes clear. Light does not reach every place equally. Across the solar system, shadow plays just as important a role as sunlight, shaping surfaces slowly and precisely. On planets with thick atmospheres, light scatters and softens. Daylight spreads gently, reducing sharp contrasts. Shadows blur. Heat distributes gradually, allowing temperatures to change slowly. This balance smooths extremes and gives motion time to settle. On worlds without air, light behaves differently. Sunlight arrives sharply, creating intense brightness beside deep darkness. Shadows remain fixed for long periods, sometimes lasting millions of years. In these places, cold becomes permanent. Near the poles of some airless worlds, deep craters never receive sunlight at all. Their walls block low-angled rays, preserving darkness indefinitely. Temperatures inside remain low enough to trap ice, even on planets close to the sun. These shadowed regions act like natural freezers, holding material unchanged across vast spans of time. Mercury holds such shadows. Though its surface can become extremely hot, ice remains hidden in permanently dark craters near its poles. Here, heat and cold exist side by side, separated only by angle and depth. The moon shows a similar pattern. Bright highlands reflect intense sunlight, while nearby craters remain in darkness. Without wind or weather, these light patterns stay fixed, slowly recording the sun's path over billions of years. Farther out, shadows grow longer. Sunlight arrives at shallow angles, spreading weakly across icy surfaces. On distant moons, tall ridges cast shadows that last for years. Ice beneath them remains colder and more stable, slowly migrating away from light. Light also affects motion indirectly. When sunlight warms a surface unevenly, gases can escape more easily from brighter regions. This creates tiny forces that gently push small bodies, altering their rotation over time. These changes are subtle, yet persistent. Dust responds to light as well. Sunlit particles gain slight momentum and drift gradually. In shadow, they settle. Over millions of years, this slow sorting reshapes surfaces, redistributing material without sound or sudden movement. Even planets with atmospheres feel these effects. Cloud patterns form where light heats air unevenly. Shadows beneath thick cloud layers can cool regions below, influencing circulation patterns that repeat endlessly. Across the solar system, light and shadow work together quietly. They guide temperature, they influence motion, they preserve history. Nothing here seeks brightness. Nothing avoids darkness. Both exist together, shaping worlds gently, patiently, and without pause. As planets continue their orbits, shadows move slowly across surfaces, then return again, repeating patterns written not in hours, but in ages. And in that slow rhythm, the solar system continues to rest, balanced between light and darkness, forever drifting, forever calm.
As light and shadow continue their quiet exchange, another truth becomes clear. Across the solar system, motion happens without sound. Space carries no air to vibrate, no medium to transmit noise. Everything moves in complete silence. Planets travel at enormous speeds, yet they make no sound as they orbit. Earth moves around the Sun at nearly 30 kilometers per second. Jupiter travels even faster through a much wider path. These motions are constant, smooth, and perfectly quiet. Collisions, when they occur, are also silent. An impact that would produce thunder on Earth releases no sound in space. Energy spreads through rock and ice instead, forming shock waves that remain trapped within solid material. Outside, silence remains undisturbed. Rockets are loud only while they pass through air. Once beyond Earth's atmosphere, engines burn in silence. Flames expand freely, uncontained by pressure, producing no roar. Movement continues without announcement. Solar wind flows outward continuously, carrying charged particles across the solar system. Though it shapes magnetic fields and auroras, it makes no sound. Its presence is detected only through instruments and effects, not through hearing. Even the sun itself is quiet. Fusion reactions release vast amounts of energy, yet no sound escapes. Pressure waves ripple through its interior, but they remain trapped within plasma. From space, the sun appears completely silent, despite its constant activity. Moons orbit planets without noise. Rings circle giants without frictional sound. Dust drifts without whisper. Everything follows its path undisturbed by vibration. This silence does not mean emptiness. It means freedom from resistance. Without air, motion remains smooth and uninterrupted. Nothing slows unless gravity intervenes. Nothing stirs unless energy demands it. On Earth, silence is rare. Wind moves leaves, water flows, even stillness carries background noise. In space, Silence is complete. It does not fluctuate. It does not fade in and out. It simply exists. This quiet allows motion to remain stable over long periods. Without drag, orbits do not decay quickly. Paths persist. Rotation continues. Balance holds. In this environment, time feels slower. Without sound to mark passing moments, movement appears gentle, almost still. The mind can drift easily, following curves instead of counting seconds. Silence also preserves. Surfaces remain unchanged without erosion from wind. Fine details last. Craters hold their shape. Dust settles and stays. Throughout the solar system, motion without sound is the rule, not the exception. Energy moves freely, but quietly. Forces act continuously, but invisibly. Nothing announces itself. Nothing demands attention. The solar system does not speak. It simply moves. And in that movement, silence becomes a kind of calm, steady, uninterrupted, and endlessly patient.
Even in complete silence, the solar system is never disconnected. Every object, no matter how small, participates in a quiet exchange that never stops. This exchange is gravity. Gravity does not arrive suddenly. It does not switch on or off. It is always present, stretching across space, linking bodies together through distance and time. Each planet pulls on the sun. Each moon pulls on its planet. Even tiny asteroids tug faintly on one another as they pass. These pulls are gentle, but they never disappear. Over time, they shape motion in subtle ways. Orbits shift slightly. Paths adjust. Systems settle into patterns that repeat for millions of years. Some of these patterns are precise. Moons can fall into repeating rhythms, completing orbits in exact ratios with their neighbors. These resonances keep systems stable, preventing close encounters that might cause disruption. Motion becomes predictable, reinforced by repetition. Gravity also stretches worlds. When a moon travels along an uneven orbit, it experiences varying pull. Its shape changes slightly with each pass, compressing and relaxing. This movement generates heat inside, even in deep cold. Ice warms, rock flexes, energy appears without fire. On planets, gravity sorts materials by weight. Heavier elements sink toward the center, lighter materials rise. Over long periods, this creates layered interiors, dense cores, flowing mantles, and solid crusts. These layers influence magnetic fields, surface activity, and long-term stability. Gravity shapes rings as well. Particles that stray too close to a planet are pulled apart, unable to hold together. Others remain safely distant, circling endlessly. The result is a thin, balanced structure held in place by countless small interactions. Even light responds to gravity. As it passes near massive objects, its path curves slightly. This bending reveals mass that might otherwise remain unseen. Through light's quiet adjustment, gravity makes itself known. Across vast distances, gravity carries information. A small change in one orbit can influence another far away, not instantly, but steadily. Over long timescales, these connections shape the architecture of the entire solar system. Nothing here moves independently. Every path is influenced, guided, and adjusted by unseen pulls acting together. The result is not chaos, but order, emerging naturally from interaction. Gravity does not hurry to correct mistakes. It allows slow drift, gentle change, and long pauses. When balance is found, it holds it carefully. This endless conversation continues without sound, without effort, and without awareness. Worlds respond simply because they must, following the curves set before them. And through this quiet exchange, the solar system remains connected. Every planet aware of the sun, every moon aware of its planet, every particle aware of gravity's presence. Nothing is alone here. Nothing needs to speak. Gravity keeps the conversation going, softly, forever.
As gravity continues its quiet conversation, another subtle exchange unfolds across the solar system. Energy does not stay locked inside a single world. It moves, slowly and gently, passing from one place to another through motion itself. When two bodies orbit closely, their gravity interacts in a constant push and pull. This interaction transfers energy over time. Orbits adjust, rotations change. Nothing happens suddenly, but nothing remains untouched. Many moons rotate in perfect sync with their planets. This did not happen instantly. Long ago, they spun more quickly. Gravity created friction within them, slowing their rotation bit by bit until it matched their orbit. Once this balance was reached, it remained. One side now always faces the planet, locked into calm repetition. Energy transfer also affects distance. Some moons slowly drift away from their planets, gaining energy from rotation. Others spiral inward, losing it. These changes are measured in centimeters per year, barely noticeable, yet unstoppable over deep time. Earth and its moon share this exchange. The moon is moving away from Earth at a slow, steady rate. In return, Earth's rotation is gradually slowing. Days lengthen by tiny fractions of a second over centuries. The process is quiet, precise, and constant. In the outer solar system, this exchange becomes more dramatic. Moons near giant planets experience strong tidal forces. Their interiors flex continuously, generating heat. This heat does not come from sunlight or radioactive decay alone. It comes from motion, converted into warmth through friction deep below the surface. This process keeps some moons active long after they would otherwise have cooled. Ice melts beneath frozen shells, gases escape, surfaces renew themselves slowly. Energy borrowed from orbits becomes a source of change. Planets also share energy with their atmospheres. Rotation drives winds. Heat moves upward, outward, and back again. Storms redistribute energy, preventing extremes from settling in one place for too long. Balance emerges from movement. Even rings participate in this exchange. Particles collide softly, trading energy and adjusting their paths. Over time, these interactions flatten structures and smooth edges, shaping rings into thin, stable systems. Energy transfer does not aim for equilibrium in the short term. It works patiently, allowing slow adjustments that accumulate over millions of years. Systems drift toward balance without ever fully reaching stillness. Nothing here wastes energy. It is transformed, redirected, or shared. Motion becomes heat. Heat becomes movement. Light becomes momentum. Each form passes gently into another. Across the solar system, this quiet sharing continues without pause. Worlds lend energy to companions, Companions respond. Paths change slightly, then settle again. No exchange is loud. No exchange is hurried. Yet through this constant flow, the solar system remains alive with motion, not chaotic, not restless, but endlessly balanced. And as energy continues to pass from world to world, the calm holds, supported by processes so slow they feel almost eternal. As energy continues to pass quietly between worlds, orbits carry on with their own kind of memory. An orbit is not just a path. It is a record of every force that has acted on a body since its beginning. Most orbits in the solar system are stable, repeating their curves again and again, but they are not frozen. Over long spans of time, they slowly change. These changes are small, almost impossible to notice in a single lifetime, yet they accumulate with patience. Gravity from nearby planets gently reshapes paths. A tiny pull during each pass adds up. Orbits can become slightly more stretched or slightly more circular. Their tilt can change. These shifts happen so gradually that balance is never lost, only adjusted. Earth's orbit has changed many times in the past. Small variations in its shape and tilt have altered how sunlight reaches the surface. Over tens of thousands of years, these changes helped guide cycles of warming and cooling. Ice advanced and retreated, not suddenly, but in slow response to orbital rhythm. Mars experiences even larger variations. Its tilt changes more dramatically, causing long periods of warming and cooling. These cycles likely moved ice across its surface, shaping valleys and deposits that remain visible today. In the outer solar system, orbits are longer and more delicate. Distant objects take centuries or millennia to complete a single journey around the Sun. Their paths are easily influenced by passing stars or subtle gravitational nudges, gently rearranging the far edges of the system. Some orbits remember violent beginnings. A collision long ago can tilt a planet or alter its spin. Even after billions of years, that change remains, carried forward with every rotation and every circuit around the Sun. Moons also carry orbital memory. Their current distances and rhythms reflect past interactions. A moon locked into resonance reveals a history of slow adjustment, guided by gravity's persistence. Nothing here forgets immediately. Motion records the past by continuing it. Each path reflects what has happened before, shaped by every encounter, every exchange of energy. This memory does not fade quickly. Without friction or resistance, orbits persist. Changes remain encoded in motion itself, not erased by time. Even the smallest bodies carry this record. Dust grains drift along paths shaped by light and gravity, tracing gentle spirals that reveal the forces acting upon them. Across the solar system, these long memories overlap. Paths intersect without touching. Rhythms repeat without conflict. Balance emerges not from stillness, but from consistency. Orbits do not rush to correct themselves. They respond slowly, allowing time to smooth transitions and maintain order. The solar system remembers because it moves, and it moves because it remembers. Each quiet curve tells a story written without words, carried forward by gravity, preserved by time. As these paths continue to unfold, the calm remains, held together by motion that never forgets and never hurries. As the solar system carries its long memory of motion, it does not travel alone. Beyond the planets and distant icy bodies, the wider galaxy continues its own slow movement. And from that vast distance, gentle influences reach inward. Stars drift through the Milky Way on wide, curved paths. Most remain far away, separated by enormous distances. Yet over millions of years, some pass close enough to feel the sun's presence and to leave a quiet mark in return. When a star passes nearby, its gravity does not disrupt the planets. The inner solar system remains calm and unchanged, but far beyond, where objects are only loosely bound, these encounters matter. Orbits shift slightly, paths stretch or tilt, motion adjusts without disturbance. In the distant outskirts, icy bodies respond first. Their long, slow orbits are sensitive to even weak pulls. A passing star can nudge one gently, changing its direction by a small amount. Over time, this change may send the object drifting inward, beginning a journey that can last thousands of years. These visitors move patiently toward the sun, not rushing, not announcing themselves. Most will never be noticed. Some will pass through the inner solar system briefly, glowing faintly, then return to darkness. The sun itself moves through the galaxy, carrying everything with it. It completes one orbit around the galactic center roughly every 200 million years. During this journey, the surrounding stellar environment slowly changes. New neighbors appear, old ones drift away. Through all of this, the solar system remains remarkably stable. The planets continue their steady paths. Their orbits are shaped far more by the sun than by any distant star. Outside influences arrive gently, never abruptly. The galaxy does not intrude, it whispers. Even the pull from distant stars follows the same rule as everything else here. It works slowly. It respects balance. It allows time for adjustment. Over immense spans of time, these subtle influences help shape the outer boundaries of the solar system. They stir distant regions just enough to keep motion alive without ever disturbing the calm within. Nothing collides suddenly. Nothing changes sharply. The solar system listens quietly to the galaxy around it, responding only where it can and only as much as necessary. Motion remains smooth. Paths remain curved. Balance holds. And as stars continue their distant passage, the solar system continues its own, carried through space, guided by gravity, and surrounded by influences so faint they feel like silence.
Even as distance increases and light grows faint, warmth never fully disappears from the solar system. It changes form, spreads out, and moves slowly, but it remains present in quiet ways. Every planet began warm. During formation, countless collisions and compressions released energy, heating young worlds from the inside out. Over time, much of that heat escaped into space, but not all of it. Some still lingers deep below the surface, moving outward at a pace measured in billions of years. On Earth, this leftover warmth rises gradually from the core. It drives convection in the mantle, powering plate movement and volcanic activity. The flow is slow and steady, allowing the surface to remain calm while the interior stays active. Mars once held similar warmth. Early in its history, internal heat fueled widespread volcanism. As the planet cooled and lost mass, that energy faded. Today, most of Mars's interior is quiet, yet traces of warmth may still remain, slowly dissipating into space. Venus holds heat differently.
Its thick atmosphere traps energy efficiently, preventing the planet from cooling as Earth did. Beneath the surface, heat may still build slowly, released only during rare large-scale events. The planet appears calm, but its interior may be storing energy patiently. The giant planets follow another pattern. They never fully cooled. Their immense size allows them to retain heat from formation. Deep inside, pressure and slow contraction generate warmth that continues to rise. This internal heat powers storms and winds far above, even where sunlight is weak. Moons, too, carry heat. Some generate it through tidal motion, others retain small amounts from their beginnings. In certain cases, radioactive elements inside rocky cores release energy slowly, adding to the warmth over long periods. In icy worlds, this heat behaves gently. It softens ice from below, allowing it to flow slowly. Cracks open, seal, and open again. Surfaces renew themselves without melting, reshaped by pressure and time rather than fire. Even small bodies feel warmth briefly. Early asteroids were heated enough to separate into layers, with heavier materials sinking inward. As they cooled, these structures froze in place, preserving chemical histories unchanged for billions of years. Heat moves outward everywhere. It always seeks balance, flowing from warmer regions to colder ones. This movement is constant but subtle, rarely noticeable without instruments. Eventually, all warmth fades, but the timescales are vast. Long after sunlight dims, internal heat will still be moving, still adjusting, still releasing energy quietly into space. The solar system does not cool evenly. Each world releases its warmth in its own way, at its own pace. And through this slow release, motion continues. Storms turn, plates shift, ice flows. Heat never rushes to leave. It departs gently, allowing the calm to remain.
As warmth slowly fades and motion carries on, one pattern becomes impossible to miss. The solar system repeats itself. Not exactly the same way each time, but close, enough to create a sense of calm. Repetition here is not boredom, it is stability. Planets rise and set again and again. Orbits loop without interruption. Moons return to the same positions in the sky, cycle after cycle. This repetition allows systems to remain balanced, even as small changes quietly accumulate. Earth experiences this rhythm every day. The sun rises, crosses the sky, and sets. Night follows. The pattern repeats, guided by rotation and orbit. While the details shift slightly over time, the structure holds. Other worlds repeat their motions on different scales. A single day on Mercury lasts longer than an entire year there, yet the cycle remains consistent. Heat rises, heat falls, shadow follows light. The pattern does not break. Venus repeats more slowly still. Its long rotation creates days and nights measured in months. Clouds circle endlessly above the surface, completing loop after loop with little variation. Change happens, but it happens slowly. On gas giants, repetition appears in bands and storms. Winds circle planets thousands of times along similar paths. Storm systems rise, drift, and fade, only for others to form in familiar regions. The atmosphere remembers where motion prefers to occur.
Moons repeat their orbits with remarkable precision. Some have followed the same paths for billions of years. Their steady movement keeps tidal forces consistent, allowing internal heat and surface activity to continue without disruption. Even rings repeat their structure. Particles circle again and again, colliding gently, maintaining flat shapes through constant motion. Gaps remain open, edges stay sharp, balance persists through repetition. In distant regions, repetition stretches across enormous spans of time. Objects take centuries or longer to complete a single orbit. Yet even these slow paths repeat, tracing the same curves through space again and again. This repetition creates predictability. Predictability creates calm. Systems that repeat remain stable, resisting sudden change. When disruptions occur, repetition helps absorb them, guiding motion back toward balance. Repetition does not mean nothing changes. It means change happens within limits. Orbits adjust slightly. Rotations slow or speed up. Heat rises and falls, but the overall pattern remains intact. The solar system relies on this quiet consistency. Without it, chaos would grow. With it, motion remains smooth, even comforting. Here, repetition is not a flaw, it is a feature. Through endless cycles, the solar system continues its work, not striving, not stopping, just repeating what works. And in that repetition, calm is preserved, allowing time to pass without urgency and motion to continue without noise.
As repetition carries on, it becomes clear that the solar system is shaped by movements so small they are almost invisible. These motions rarely draw attention, yet over long stretches of time they quietly reshape everything. A planet's rotation can slow by tiny amounts each century. A moon can drift a few centimeters farther away each year. Dust can settle by fractions of a millimeter over thousands of seasons. None of this feels important in the moment, but given enough time, these changes become permanent features of the system. Earth's rotation is gradually slowing. The difference is so small it requires precise instruments to detect. Yet over hundreds of millions of years, days have grown noticeably longer. The planet did not decide to slow. Gravity simply continued its work. The moon's distance from Earth increases slowly as energy transfers between them. This change alters tides just slightly, stretching their timing across deep time. Oceans respond gently, adjusting without disruption. Elsewhere, small forces shape entire worlds. Sunlight pushes tiny particles of dust, altering their paths bit by bit. This effect is weak but constant. Over long periods, dust migrates, surfaces darken, and thin layers accumulate. Even a planet's tilt can change slowly. Gravitational interactions cause axes to wobble over thousands of years. These movements adjust how sunlight reaches the surface, influencing climate patterns without sudden shifts. Asteroids experience similar influences. A slight warming on one side can cause material to escape unevenly, creating a tiny thrust. Over time, this can alter spin rates and orbits, redirecting paths gradually. On icy moons, small cracks can open with each orbit, then close again. Each cycle moves material by an almost unnoticeable amount.
After millions of cycles, surfaces appear renewed, smoothed, and rearranged. These changes never hurry. They rely on persistence rather than force. Each step is small enough to maintain balance, allowing systems to adapt without collapse. The solar system favors this method. Large events are rare, small adjustments are constant. Together, they guide evolution without interruption. Time here does not measure progress in days or years. It measures it in accumulated motion. Tiny effects add together, shaping outcomes that appear dramatic only when viewed from far away. Nothing needs to be pushed. Nothing needs to be rushed. Small motions do their work quietly, trusting time to finish what they begin. And as these subtle shifts continue across planets, moons, rings, and dust, the solar system remains calm, not because nothing changes, but because change arrives gently, one small movement at a time. As small motions continue to shape the solar system, distance begins to feel different. Far from the sun, space does not feel empty or harsh. It feels gentle, stretched, and unhurried. Here, everything happens with extra patience. Light takes longer to arrive. Signals weaken. Heat spreads thin. Yet motion remains steady. Objects far from the sun still know exactly where they belong, guided by gravity that reaches farther than intuition expects. Distant planets move slowly along wide paths. Their years last decades or centuries. Nothing asks them to hurry. With each orbit, they trace the same curve again, confident and calm. In these regions, temperature changes are subtle. Sunlight arrives faintly, barely warming surfaces. Worlds rely more on stored energy and internal processes than on external heat. Change becomes quiet and predictable. Moons in the outer system often remain locked in stable patterns. Their orbits are slow and measured. Tidal forces act gently, maintaining balance rather than disruption. Nothing jerks or pulls sharply. Dust behaves differently here as well. With less sunlight to push it, particles drift more slowly. Some remain suspended in stable paths for millions of years, rarely disturbed. Even time seems to stretch. A single rotation may take many Earth hours or days. Shadows move gradually. Light shifts almost imperceptibly. This slowness allows systems to remain calm, resisting sudden transitions. Signals sent across these distances weaken naturally. Radio waves spread out. Light fades. Nothing is lost suddenly. Everything diminishes gently, respecting distance rather than fighting it. Spacecraft traveling far from the sun must adapt to this environment. Solar power weakens. Communication delays grow longer. Commands take hours to arrive. Responses return just as slowly. Exploration becomes a practice in patience. Yet even here, guidance remains precise. Orbits can still be calculated exactly. Motion follows the same rules everywhere. Distance does not change the laws of physics. It only changes the pace. The farther one drifts, the more the solar system feels like a single connected structure rather than a collection of separate worlds. Gravity links everything. Motion carries memory. Distance adds calm rather than separation. Nothing is truly isolated. Nothing is forgotten. Even the most distant object remains part of the same system, following a path defined long ago and still maintained today. Here, distance does not mean loneliness. It means space to move gently.
and as the solar system stretches outward, carrying its farthest members along wide, patient paths, calm settles even deeper. Held together by gravity, softened by distance, and guided by time.
As distance softens motion and time stretches gently, balance becomes the defining feature of the solar system. Nothing here is perfectly still, yet nothing falls apart. Balance is not the absence of movement, it is movement arranged just carefully enough to last. Every orbit is a balance between two tendencies. One pulls inward, drawing objects closer together. The other carries motion forward, preventing collapse. When these forces match, paths become stable. Worlds circle endlessly without drifting away or falling inward. This balance is not fixed forever. It adjusts slowly, responding to small changes without losing form. When mass shifts or energy transfers, orbits adapt. The adjustment is gentle, spread across time, allowing stability to remain. Planets demonstrate this balance clearly. Each follows a curved path shaped by gravity and speed. Too little motion would cause a fall. Too much would cause escape. Instead, each planet moves at just the right pace to remain bound. Moons follow the same principle on smaller scales. Their orbits depend on distance, mass, and speed. When balance is achieved, the motion repeats quietly. When it is disturbed, gravity guides the system toward a new arrangement rather than chaos. Even rings rely on balance. Particles that move too slowly drift inward. Those that move too fast drift outward. Over time, collisions and gravity smooth these motions, concentrating material into thin, stable layers. Asteroids demonstrate balance through separation. Though they share regions of space, they remain far apart. Their spacing reduces interaction, preserving long-term stability. The absence of frequent encounters is itself a form of balance. Balance also governs rotation. A planet spins at a pace shaped by past collisions, gravity, and internal structure. Over time, rotation can slow or stabilize, reaching a state where change becomes gradual rather than dramatic. Atmospheres reflect balance as well. Gases are held by gravity but energized by heat. Too much energy and they escape. Too little and they settle. Each atmosphere exists where these influences meet gently. Throughout the solar system, balance prevents extremes. It allows storms without destruction, motion without collision, and change without collapse. Balance does not demand perfection. It allows variation within limits. When disruptions occur, balance absorbs them slowly. Paths adjust, energies redistribute, calm returns without force. This is why the solar system lasts, not because nothing happens, but because everything happens carefully. Gravity pulls, motion responds, time allows adjustment, and through this quiet cooperation, balance holds, keeping worlds in place, keeping motion smooth, and allowing calm to persist without effort. With balance holding everything in place, change in the solar system takes on a very specific character. It never feels rushed. Nothing here is in a hurry to become something else. Change happens, but it arrives gently, spread across time so wide it almost feels like stillness. Planets evolve slowly, their interiors cool,
Their surfaces shift, their atmospheres thin or thicken. These transformations are measured not in years, but in millions of years. A mountain rises so slowly that it never feels like movement. An ocean disappears one molecule at a time. Stars change as well, though even more patiently. The sun has been shining in nearly the same way for billions of years. Its output changes only slightly, allowing planets to adjust without disruption. Nothing sudden interrupts the rhythm. Orbits continue to adjust quietly. Tiny gravitational interactions accumulate. Paths stretch or round out almost imperceptibly. Yet these changes never break the system. They refine it, smoothing motion rather than disturbing it. Moons evolve through slow exchanges of energy. Some drift farther away, others move closer. Over time, these shifts reshape tides, rotations, and internal heat. The process is constant, yet so gradual it feels invisible. Atmospheres respond to change in the same way. Gases escape slowly. New compounds form. Light breaks molecules apart and allows others to assemble. Over long spans of time, a planet's sky can transform completely without any moment standing out. Even impacts follow this pattern now. Large collisions are rare. Most change comes from small particles, gentle contact, and gradual accumulation. Dust settles, ice migrates, surfaces darken or brighten slowly. This pace allows stability to survive. Sudden change would disrupt balance. Slow change allows systems to adapt continuously, maintaining calm while still evolving. The solar system favors this approach. It allows worlds to change without forcing them. It gives motion enough time to settle before asking it to adjust again. Nothing here demands attention. Nothing insists on speed. Change becomes part of the background, unfolding quietly while balance remains intact. This is why the solar system feels peaceful, not because it is unchanging, but because change arrives softly, without urgency. Time does the work. Gravity guides it. Motion carries it forward. And as this gentle evolution continues, the calm deepens. Not frozen, not fixed, but endlessly patient. As gentle change continues without urgency, the solar system begins to reveal its future, not as a sudden event, but as a slow unfolding already in motion. Nothing here waits for a single ending. Everything moves toward what comes next at a careful, measured pace. The sun continues its steady work, converting mass into energy moment by moment. This process has been stable for billions of years and will remain so for billions more. Light will keep spreading outward, touching planets, moons, rings, and dust, maintaining the balance that allows motion to continue calmly. Over immense spans of time, the sun will slowly change. Its fuel will shift. Its structure will adjust. But even this transformation will not arrive quickly. Planets will have time to respond. Orbits will adapt. And systems will settle into new arrangements without sudden disruption. Closer worlds will feel these changes first. Temperatures will rise gradually. Atmospheres will respond slowly. Ice will retreat, migrate, or vanish over long periods. Nothing will happen all at once. The solar system allows room for adjustment. Farther out, change will arrive much later. Distant planets and icy bodies will continue their slow paths almost unaffected for a very long time. Their environments are shaped more by internal processes and distance than by immediate sunlight. They will remain calm while the inner regions transform. Moons will continue their quiet relationships. Some will drift farther away, others will move closer. Tidal interactions will slowly reshape rotations and internal heat. These processes will continue regardless of larger changes, following gravity's steady guidance. Rings will thin and fade. Particles will slowly fall inward or drift away. New structures may form briefly, then dissolve again. Even these changes will be gradual, allowing balance to remain. Dust will keep moving. Small bodies will keep drifting. Comets will continue their long journeys, appearing briefly before returning to darkness. The outer regions will remain filled with quiet motion and long memory. Throughout all of this, the solar system will not lose its calm. Motion will continue to repeat. Orbits will remain smooth. Gravity will still connect everything, even as conditions slowly evolve. The future here is not dramatic. It is patient. There is no single moment where everything changes. There is only continuation, one state gently becoming another, guided by the same rules that have always applied. This is the long quiet ahead, a future built from the same calm motion that shaped the past. And as the solar system carries on toward what comes next, it does so without urgency, without noise, and without resistance, moving forward the same way it always has, slowly, steadily, and in balance. As the journey settles into its quiet future, one truth remains unchanged. The solar system never truly arrives anywhere. It continues moment by moment, held together by motion that does not seek an end. Right now, planets are still orbiting, moons are still circling, dust is still drifting, light is still traveling outward from the sun, spreading thinner as it goes, yet never stopping. Nothing has paused while we've been drifting through these thoughts. Earth continues its rotation, turning night into day and day back into night. Oceans move in slow rhythms. The moon keeps its steady distance, guiding tides without effort. These motions feel familiar because they repeat so reliably. Elsewhere, Mars continues to turn beneath its thin sky. Jupiter's clouds keep sliding past one another. Saturn's rings still circle, particle by particle, each following its own path. Uranus and Neptune remain tilted and distant, holding on to their slow seasons and quiet winds. Far beyond, icy worlds continue their long journeys. Some will not complete a single orbit during all of recorded human history. Yet even these distant bodies move with certainty, guided by gravity that has never lost its strength. Nothing in the solar system waits for permission to move. Motion is not optional here. It is the natural state. Stillness exists only as an illusion created by scale and distance. Even the sun, which seems like an anchor, is traveling. It carries the entire system along as it moves through the galaxy, completing a vast orbit of its own. Every planet, moon, and grain of dust is part of that larger motion, whether noticed or not. Change will continue quietly. Rotations will slow. Orbits will adjust. Heat will fade and redistribute, but balance will hold as long as gravity remains. This is why the solar system feels calm, not because nothing happens, but because everything happens at a pace that allows harmony to survive. There is no final stillness ahead. There is no sudden ending waiting, only continuation. Worlds will keep turning, paths will keep repeating, forces will keep working together,
without sound, without urgency, without interruption. And even now, as thoughts begin to slow and attention drifts, the solar system carries on, unchanged by observation, untouched by rest. Nothing asks to be watched, nothing needs to be understood fully. It simply moves. And in that motion, calm remains, steady, ancient, and patient, drifting onward long after sleep arrives.